Hello everyone, welcome to our Graphing Rational Functions Notes Day. Hopefully we only have a few more before we go back to school, so a couple of reminders. Make sure you jump on a Hangout if you need. If you have questions, if you haven't done that yet, make sure you're communicating with your teachers. So as we start our graphing with our rational functions, we're going to sorry it took up the whole page. Hopefully y'all can see it. I kept trying to make it smaller, but if I make it smaller, it's too hard to write on. So we're just going to deal with it. I figured y'all be okay with it. So remember, we like to start with a table. We've not graphed a function like this before, so we want to kind of explore it and see what it looks like. And I'll explain things to you as we do that. So if you're used to being in my class, we like to start in the middle of the table and put our 0 there, because 0 is our favorite number. We want to put 0 there. Notice when I plug 0 into my function and I have 1 over 0, we know when a 0 is in the denominator that that's not equal to 1. That is undefined, meaning there is no value there. So we'll just write UND for undefined. We'll come back and talk about what happens to the graph there, but we just need to know that we're not going to plot anything where x is equal to 0. Now we move up, we'll go to 1. So when x is equal to 1, that means my equation is 1 over 1, which 1 over 1 is just 1. So I could plot that point 1, 1 on my graph. Do the same thing with 2. I'm going to have 1 over 2. That gives me 1/2. I don't need to write that again. That just gives me 1/2. So when I plot 2, 1/2. And then when I plot 3, I would get 1/3. So 1/3 is going to be really close. 1/4 would be even closer. 1/5 would be even closer. 1/6 would get even closer. But would it ever actually touch that graph the bigger the number gets? Well, even if we went to 100, that would be 1 over 100, or 1/100th. And it's not actually 0. So we won't ever actually get to the graph on here. And if you notice, if we go the other direction, -1, we're going to have 1 over -1, which we all know is just -1. So if I plotted that, notice it hops over here, and I have a point just like this one, but on this side, in the bottom, in the third quadrant. And then if I did -2, notice I would have -1/2. So it looks very similar to this over here, but it's going the opposite direction. And when I do -3, that gives me -1/3. So it's getting, again, it's getting closer. So we say that it's approaching that value. It's approaching that that x-axis. So as it approaches that x-axis, that means my x-axis, we're going to make a dashed line right here, because that represents a special line. It is not part of our graph. That's why it's dashed. That is the equation, y equals 0, and that's what we call a horizontal asymptote. ASYMPTOTE. A horizontal asymptote. What an asymptote means is that my graph is going to get close, 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 but it's never actually going to touch it. So we're just going to get as close as our pencil can get, and then we're just going to draw an arrow on the end. And then we're going to do the same thing as we go this way. As my negative values become more and more negative, I get close and close and close to there, but I'm never actually going to get to a y value equal to 0, so I can't cross over there. Now, let's explore a little bit about what happens in here between 0 and 1. So, if we go back to our table, that's why I have another table over here, and let's explore some of those values. Like, let's do some easy ones, like 1/2. If my x value is 1/2, well, let's think about what that really means. I'm just going to do my work over here so you can see. If my x value is 1/2, that means I have 1 over 1/2. Which that really means that's the same as saying 1 divided by 1/2, right? And we just did a whole bunch of work on this, so hopefully you remember division with fractions means keep the first, change it to multiply, and flip the second one. So when we flip that to 2 over 1 and multiply, that just gives me a 2. So 1/2, 1 over 1/2 gives us 2. So what do you think 1 over 1/3 would give us? Well, if I did 1 divided by 1/3 and I flipped it, do you see that will just give me 3? So if I were to plot those, if x is 1/2, my y value is 2. If my x is 1/3, my y value is 3. So if my x value is 1/4, it'll be 4. 1/5, it'll be 5, and so on. So it just gets close and close again, but this way in the vertical direction. Well, let's see what happens going negative. Well, what do you think will happen if we have a negative 1/2? If I just made this negative, 1 over negative 1/2 would be 1 divided by negative 1/2. So 1 times negative 2 would give me negative 2. So therefore we could conclude that 1 over negative 1/3 would give us negative 3. And notice it does the same thing going in the other direction. So again, when I connect those, it's going to get close and close and close, but it's never actually going to touch that y-axis. And for those of you that are not normally in my class, if you've just joined us, my students could tell you how incredibly wonderful that is, because I never draw graphs good that first time. So y'all are fortunate. So this also gives us a vertical asymptote. So we're going to draw us a vertical line going up and down. And yes, I usually use the vertical tool, the line tools, if your teacher usually uses those, but I wanted to make those definite so you could really see those well. And I can do that with my pencil pretty good. So this is the line, x equals 0. And so this now represents a vertical asymptote. A vertical asymptote. And if you do any of the work on IXL, if that's how you choose to do your work, they'll also talk about an excluded value. And the excluded value they're talking about is which of those x values does not work. Well, remember on our table, we talked about this value of 0 giving us an undefined value. That 0 is our excluded value. We have an excluded value of 0. X cannot be 0. If you think about our domain, when we write the domain of a graph, our domain in this case would be all x values not equal to 0. Every other x value is a good x value. Only this one isn't. And it's always whichever one that vertical asymptote is. Your range would be all y values except y equal to 0. Okay? Now, just to fill in your little equation, this should look familiar to you. You should be used to seeing x minus h, and you should be used to seeing a plus k on the end. Everything basically works the same. I have color-coded it to help you to remember that your h right here, remember it's attached to the x value. So that's going to give us a horizontal shift. And remember, it always goes opposite the direction you think. We think minus means it's going to go left, but minus, when it's x minus h, that actually means it's going to go to the right. This will also give you that vertical asymptote. I'm just going to put ASY for vertical asymptote. Now, your k value, you should be used to what the k does. The k helps you move up and down. So that gives us our vertical shift. And remember, it's always the same. So when you see a plus, you know you're going up. When you see a minus, you know you're going down. Therefore, that is your horizontal asymptote. Okay? And then your number on the top will tell you your reflecting or your vertical stretching, just like everything else did. Now, I will do an example with you to show you what a vertical stretch will look like, and I will use those color codings so that you can see those asymptotes as well. Okay? So the easiest thing to do is to do that vertical asymptote first. Notice we're looking at the denominator. We don't have anything added or subtracted, so we know our vertical asymptote is going to be at x equals 0. Whenever you draw your asymptote in, it's always good to go ahead and label that so you don't have to go back and think about it later. Now, we don't have anything added onto the end, so we have a 0. So we know we're going to have a horizontal asymptote at y equals 0. So go ahead and label that on your graph. Now, our negative tells us that we're going to have a reflect, and the 2 tells us that we're going to stretch, have that vertical stretch. So everything else is pretty much the same. So if you go to your origin, remember we always had that point at 1, 1. But now my y value is multiplied by a 2, and we have to flip it over. So instead of my y value being at 1, 1 times 2 gives me 2, but I want to reflect it over. So that value moves over here. Now remember we were at 1/2 here at x equals 2. So if I take 1/2 and I multiply 1/2 times 2, that's going to give me 1, but then we want to reflect it. And you really only have to do a couple of points and you're okay. So if you remember, originally our 1/2 would have been at 2. If I stretch that, it would go to 4, because 2 times 2 is 4, and then we're going to reflect it over to the negative. Okay? And then these same points happen on the opposite quadrant. So if this is in quadrant 4, those points are also going to be over here. So this was 1, -2. We're going to be at 1, +2. And it does the same as taking that -1, stretching it, and flipping it. Okay? So we would have 1 at -2, 1, and then 1 at 1/2, 4. And then we could connect our graph. So wish me luck, because my drawings, see, they're usually not all that pretty, but we're not looking for exactly how pretty they are. We're looking for your asymptotes and that you did graph it. Don't just slap it on there, but draw your points. We're looking for the points, and we're looking for that you're going through those, and it does look like a curve. Okay? So same thing here. It should go through my points and look somewhat curved along our graph. Remember, you can plug these into Desmos. If you would like to double check your graph, you can certainly do that. And then we have a few things we want to name. We want to name all of these things: vertical asymptote, horizontal asymptote, domain, range, and our excluded value. And if you labeled your graph correctly, you should have everything listed over here already. Our vertical asymptote, we labeled it as x equals 0. Oh, I wanted to do that in colors for you, sorry. Our vertical asymptote at x equals 0. Our horizontal asymptote was y equals 0. Make sure you're labeling those. Your domain. Our domain are our x values, so I'm going to do those in orange just like I did the vertical, and list that as x is not equal to 0. And then your range, your y values, y is not equal to 0. And then our excluded value is always the same as that vertical asymptote. Okay? So good luck on your assignment. If you have questions, make sure you check in. Jump on a hangout if you need to. So good luck to you guys. Sorry this one was fast, but there was a lot of stuff to talk about. So y'all have a good day. Bye-bye.